Alright, so today we will be tackling the topic of if statements. What they are, how to use them, why they are useful. So, I got an example ready, but the first thing I think we should talk about is maybe the top-down view of if statements, why they're useful. Let's say, for example, let's do this. Let's make some geometry. Let's just make a sphere. And let's actually make this a polygon mesh, and that's fine. And then let's say I want to do some stuff to this sphere. For example, a pretty common thing that you'll be doing is assigning maybe some type of color. So we can do that. I mean, we can go at CD equals. Now, there's one kind of interesting thing. So I could do this, for example, in order to set all of my points to black. But I want to introduce really quickly in this lesson the whole concept of the set function in Houdini. Notice it pretty much does the same thing. But I like using the set function when you're dealing with vectors, because sometimes it's a little bit hard to remember to use the curly braces for a vector, right? Like if I do with just parentheses, it's not gonna work, or it might work. Yeah, it looks like it knows to kind of convert that. Let's test. Let's make it all white. So yeah, it looks like Houdini actually kind of knows what I meant. But there's other reasons to use the set function, which is mainly that it's a lot faster. So if you start to scale up your effect and you've got a lot of geometry, using the set function to set your vectors to certain values is always going to be faster. So basically, all I'm doing is I'm taking a vector, right? We know that color is a vector, right? Here it is. It's got its 3 components to it, RGB. You could call these X, Y, Z. It really doesn't matter. And I'm basically saying, okay, set the first component to 0, the second component to 0, and the third component to 0. So now we immediately run into a little bit of a problem, because what if I wanted the top half of the geometry to be white and the bottom half to be black? Well, geez, I guess I could do that. I could maybe clip this. So let's actually just get rid of this for a second. So we'll clip the top half, and then what we could do is we could, whoops, I'm not the greatest at wiring nodes. So maybe this will be the top half, and then this will be the bottom half. You'll be like, why is he doing it this way? But I'm explaining why if statements are useful, basically. But so if we go, for example, -1, that's the bottom half. Okay, so I got it split up. So now I can color the top half black, and then we'll copy this over, and we'll make the bottom half white. And then we'll go ahead and merge them back together. Whoops, not file merge. No, thank you. Merge these two back together. Okay, but now I got these problems because these points are separate, or maybe they're not, but they're definitely not stitched together properly. So now we've got to fuse Okay, and that kind of screwed everything up because now these points didn't know, like, do you want me to be black or do you want me to be white? So major headache, right? This is really just not a great solution for our problem. So enter if statements. Why are if statements so powerful? It basically creates a fork in the road. So you're deciding what you want to do on your effect, and you get to the point where you're like, well, you know, I want these guys over here to do something, but maybe not these guys over here. And that's a situation that comes up a lot in computer programming. We sometimes call it like branches of logic, right? So, or sometimes you call it the logic structure of your computer program. And basically what an if statement will do is the computer will run into an if statement and it will say, oh, you want me to maybe do something some of the time, and then maybe other the times you want me to do something else, right? So that's, I think, the easiest way to think of an if statement. It's like putting a fork in the road, so that all of your whatever you're trying to code, it doesn't all have to follow the same river. You know, it has different streams or different smaller rivers branching off from the main river. That's kind of the way to think about if statements. And I'm going to repeat certain topics in these lessons a lot because they're so important and they took me so long to understand. So I'm just going to kind of keep repeating them. And one of the things I'm going to repeat is that remember that the point wrangle nodes, right, these vex nodes, they run on all of the points at the same time, right? So every single one of these points is getting the same instructions. If I go at cd equals set, and then I set this all to black. Whoops. Right? All of these points are getting the same instructions. But now, what if I do this? What if I say, you know what? Point number 1, I want you to be, I don't want you to be black. I would actually like you to go ahead and be red. Now it might be tricky to see because the red point. See, there it is. Here's point number 1. So if we go to our if we display our point numbers, here's point number 1. Wow, really cool. That's really powerful, right? Because like we didn't have to chop this up, and right, we were able to kind of control the instructions that we were giving the geometry based on the if statement. So let's break this if statement down. There's 2 main components to an if statement. You have what's called your conditional, okay? And then you have your code, basically. And the good news is, this part, you don't have to learn anything new. It's pretty much anything that you could already code in Vex, you could pretty much put in an if statement. I think that's actually an accurate statement. So, for example, we're setting a color up here. We know how to set a color, so we can just do that inside of our if statement, right? So any of the stuff, any of the Vex tricks and techniques that you've learned, you can put inside an if statement. So really, we don't have to be too overwhelmed. We just kind of have to learn about this new stuff with the conditional and then a little bit of formatting. So, let's talk about the formatting first. So whenever you're writing a new if statement, you're going to start with if, right? That seems pretty self-explanatory. And then you're going to use parentheses, and then you're going to use a pair of curly brackets. But generally, this is how I'll start writing an if statement. If I'm really kind of trying to stay organized, I'll go if, I'll do my parentheses, I'll do an open curly brace, I'll hit 2 enters, and then I'll do a closed curly brace. And now, this is kind of like the skeleton of my if statement. And now because the problem is if I start out doing this, if point number is equal to 1, then do a bunch of stuff. The problem with this is that I might forget to close my curly brace, and then I've got this huge long piece of code, and I'm hunting all through it to try to find places where I forgot this, right? So when you're first starting out, and honestly, even if you're a veteran, I really recommend just getting this into place first when you're writing your if statement, because that way you know no matter what, my formatting is correct and I won't have any weird errors. Because when you have weird errors, like forgetting to put a curly brace, sometimes you think that you wrote something wrong, like your coding might be off, and that can be really frustrating because you're like, I thought I knew this. Why isn't this working? And this used to happen to me all the time. And it's really unfortunate because you start to second guess the stuff that you already know. Even though that stuff is really solid, it was really just kind of like a silly formatting error. So we start out like this. So a lot of times I'll maybe start with the code that I want to have happen. And one of the conventions is to go ahead and indent inside your if statement. It will not affect how the program runs. The program will run perfectly fine if you do this. But it's just well, I don't have an if condition. That's why it broke. But let's just for argument's sake, let's say if at ptnum is equal to 1. So notice how it worked just fine, right? Our point number 1 is red now. But when you're talking about working with teammates, or even when you're looking back on your own stuff, it's really better to indent inside an if statement, because now, like, what if I had a bunch of lines, right? A bunch of lines of code. Well, now when I'm looking back on this, I can very clearly see, oh, all of this is what happens inside of this if statement. So that's basically a way to think about it. And then for the conditional, now the conditionals, this is where you kind of have to learn different conditionals inside of Vex. Let's just start with 3 very simple ones. There's a lot of power in just these 3, and we'll just learn them. So the first thing we can do is we can test if something is equal to. Now, a beginner trap that I used to run into all the time is I would go, okay, if your point number is equal to 1, then I want you to do your thing. What? What the hell just happened? This is really strange. And this will throw a lot of people for a loop. The key is, what does the equal sign actually represent in the world of Vex, right? Well, if we bring in some computer science terminology, the equal sign is what's called an assignment operator. That's a scary little 2-word phrase, but it's actually not that difficult if you break it down. What an assignment operator does, which is what the equal sign is it looks at the left side of it. So here's our assignment operator. So it says, okay, I see you, Mr. Left-hand thing. And it basically takes the left-hand thing and assigns the right-hand thing. So, for example, when we were making an integer, let's say we'll call it my number, and we set it equal to 1, right? What we're really doing is we're assigning the value of the right-hand side of this operator to the left-hand side, which is this integer. So now whenever I say my number, I really mean 1. It's a little bit confusing. Take some time to really rewind that part and let that sink in, okay? The assignment operator is taking whatever on the right side and it's giving that value to the left side. I think that's the easiest way I can explain it without getting too much more technical than that. So if we look at what's going on here, our if statement is actually nonsensical, because it's basically saying, I'm going to take all of your point numbers and assign them to 1. Well, that's not very useful, right? I mean, we want all of the points in our geometry to have their own point number. So this is just silly, basically. So if I want to test if your point number is equal to 1, you actually need 2 equal sign. And the way that I kind of am able to remember this is I always say it out loud in English when I'm coding. So I'll say, for example, if I'm coding this example, I would be like, okay, if your point number is equal to, so something about that is equal to kind of forces me to put 2 equal sign, right? I go, is equal to 1. And that's how I don't forget that. So if your point number is equal to 1, then go ahead and do your thing, right? So that's the equals. Now, the other two, sorry, I had to sneeze. The other two are actually much easier. They're simply the less than and greater than sign. So let's say maybe your point number is bigger than, is bigger than, like, let's say 15. Now notice I got a lot more red there. Well, that's because most of these point numbers are bigger than 15. If we look at our points, we have 265 points here. So if you think about the number 265, that's a lot of numbers that are bigger than 15. So let's try something more like in the middle, like 265 divided by 2 is roughly like 132. So if I do this, it should be about half the sphere. Yeah. So now basically what's happening is we're saying if your point number is bigger than 132. So remember, Vex runs on all of the points at once, right? So all of these individual points, they're basically checking their point number, and they're saying, like, for example, Mr. 1 is saying, okay, I'm 1. Am I bigger than 132? Well, no. 1 is not bigger than 132. I'd rather have $132 than $1, right? So clearly that's not true. So Mr. 1 says, oh, I'm not bigger than 132. Okay, I don't need to worry about this. This is not for me. This is not my stream. It's like, think about it as all of the points are in their own little individual boats, and they're flowing down one big river. And there's certain little tiny streams that kind of shoot out to the offside. And basically the points are constantly checking these conditions. And if it meets that condition, like for example, Mr. 265 says, oh, wait a minute, I am bigger than 132, aren't I? Okay, that's the stream that I need to go down. This if statement creates a new stream, but it's only for certain points that will pass this condition. You see? So this example is a little bit silly, and it's not exactly practical. So let's actually take this and apply it to a real visual effects scenario and see how we can maybe utilize this. So because spheres are boring and everyone uses them in every example, we're going to actually do a different type of geometry here. We're going to take a platonic solid and we will use a octahedron. So we get this cool diamond thing. And what I'm going to do is I'm going to go ahead and use an I'm going to use a ISO offset node, and all this does is it's just a nice convenient way. Let me actually show you why I'm using this. So if I were to drop so I'm trying to get some points. So if I drop a scatter node now, it looks nice, right? But if you look really closely, here, let me actually turn this into 5,000. It might be easier to see. Or actually, let's go less. It's kind of difficult to see, but basically what's going on here is that it's scattering the points on the surface of the geometry, and I don't have anything on the inside. And that's what happens when you take a surface and you feed it to the scatter node. It basically says, oh, let me look at all of the surface area of your object, and I'll go ahead and scatter some points. But I want this to be kind of like a more solid thing. So what I'm going to do is I'm going to first turn it into a volume using this ISO offset, and it gives us a pretty rough volume. So I want to actually take the sampling up a little bit. I just want a better representation of my diamond. And then I will go ahead and I'm going a little fast through this part, but the main point of this lesson is if statement. So I'm don't worry if some of this stuff is confusing, but so now when I go ahead and use my scatter node, notice now it's basically filling the entire shape basically. So that's kind of a cool little trick. So if you ever need to fill an entire shape with points, you don't want just the surface, you can go ahead and turn it into a volume. So now what I want to do is just to make this kind of more interesting, I'm going to do some animation on this. And what I'm going to do is I'm going to go through this a little quickly because I don't want to get too bogged down in this part of the tutorial. But basically all this stuff, if you're following along the Joy of Vex tutorial, all this stuff you should be able to basically do at this point. So sorry about not explaining it, but I just don't want this to be a absolutely huge video that no one watches through the whole I want this to basically be somewhere where people can go to understand if statements and not have to be bogged down in my bullshit. So alright, so I basically just created a something that kind of creates some animation. If I play this back in real time, you'll see kind of what I've done. So like generic glowy particle thing, right? Like we do this effect a million times, right? So let's say we've got this going on. So we come to the time where we want to color it, and our visual effects director comes in. He says, "Hey, you know what? I was thinking it would be kind of cool is if the top half of your particle effect is red and the bottom half is blue." And you're like, "Oh yeah, I could do that easy. I could just use an if statement." So let's get a point wrangle down, and this is the part I'll go into detail. I won't skip anything here. So when we're dealing with color, generally a great place to start, depending on the effect, is to just set everything to black, right? Because black is kind of the default. It puts zeros in all of your channels, and it basically just is a good starting point. So I just went ahead and I took the color vector RGB and I set all of the values to zeros, right? We talked about the set function, why it's faster, why it's better than manually setting it. So now, okay, so we're thinking about our effect and we're like, okay, well, we need some if statements, so let's go ahead and use our template that Andrew taught us. I want two different streams, right? Because I want two different things to happen. I want a stream for if the points are in the top half of the geometry, and I want a stream for if they're in the bottom half. Well, now we could probably figure this out if we just kind of think about it. Like, okay, what can we use to say the top half? Well, we don't really know. Like these points are kind of flying around all over the place, right? I've got an error, so let's just back up here. So if we look at these points, I'm going to actually reduce this a lot, just so we can see better. But if we look at our point numbers, your first thought might be we can use the point numbers to help us, but it's kind of random, right? I mean, here's point number 9 up here, and here's point number 49, number 15. There's really no rhyme or reason. So the point number might not be the greatest thing to do. So my first instinct, let me actually give us some more points. My first instinct was to be like, okay, what if your Y position was bigger than 0? Okay, and then if your Y position, so at p dot y, right, that's how you access each individual point's Y position, and let's say your Y position was less than 0. And now we can say at CD is equal to, we'll set the top half to be red, and the bottom half we will set to be blue, but I don't actually like the color that you get when you go when you just fill the blue channel. If we look at this here, you can see this blue is like it's a little dark for me. So what I'll do is I'll bleed a little bit of green into that channel to brighten it up, and I like the color of this blue a bit better. It's a bit easier to see as well. In fact, let's brighten that up even a little bit more. So there we go. So now we've got our cool little effect, but not exactly working how we want. But there is something kind of cool going on here that I want to point out. So we do have, our code is working. I mean, if you look at this grid here, right, this plane represents exactly the cutoff of the y coordinate system. So if we zoom really close, we can see that anytime one of these points falls below this plane, it turns blue. And the cool thing about this is that it changes dynamically, because Vex evaluates every frame, basically. So it's going to be hard to see because they're moving a little fast, but if a particle is red and the animation that I have on this, if it causes it to dip below, it will actually turn blue. It might be a little easier to see at the beginning. Yeah, see, there's some particles kind of changing color there. So that's really cool, because now instead of basically having all of your like half of your particles be red and half of your particles being blue, and then they just move around, now there's like a secret door, right, where when the particles cross through it, they change color, and it might be a cooler like effect than just doing it like a more standard way. But we still have a little bit of a problem here, because we want the top half to be red and the bottom half to be blue. Well, if we look at what happened, so here's our points, and when I applied my noise, it just kind of moved everything a little bit too much. Now, the temptation here would be to find a way to basically bring this back to the center, and if we could do that, then this code would work. But an easier solution is to actually use another cool trick that you guys have learned if you're following along with the joy of Vex, which is to use a bounding box. So rather than using the global kind of Y position of each point, I'm going to basically create a bounding box that will basically it will follow the geometry around. So now, no matter where we move our effect, our cool little coloring process won't break. So we're going to basically keep a lot of this code, but we need a bounding box. So a bounding box is a vector. So we'll do vector, and we'll call it bounding box. And if we do relative point BB box, this is a really powerful function because it only takes 2 arguments. Firstly, it takes your geometry input stream. So notice how in your point wrangle nodes there's 4 different inputs. So a lot of functions in Vex, they need to know, hey, which one of these geometry streams do you want me to work on? Do you want me to work on, remember in computer science we start counting at 0. I know that's a little frustrating, but so do you want me to work on stream 0, stream 1, stream 2, or stream 3? Well, if we look at our node, we only have something coming into stream 0, so that's probably what we want it to work on. So that's why a 0 goes first. And then the next thing that it needs is it needs the position of the thing that you're trying to make a bounding box around, which is, of course, at P. So what this basically will do is it will look at geometry stream 0, which is all of this stuff, right? And then it will look at all of the positions of these points. So it's going to look at all of these different positions. And then it's going to basically create a relative bounding box around that. So if you picture like a cube around, like a bounding box cube around our geometry, that's basically what we've created here. So now what we can do is we don't have to change our colors, right? We like our colors, but what needs to change is our conditionals. So, um, so let's say if, and remember, a bounding box is a vector, right? So actually, let's do this. Let's print out. So let's do so we'll do a new vector attribute called. Remember our trick where we print out our values to our spreadsheet to see what they are. So we can do this, right? And now you can see kind of what's going on here. So every single one of our points, right, now has some bounding box information. And these X, Y, and Z numbers, they just represent where that point's position lies relative to the bounding box. Okay? So globally, we have our P value, right? So point number 0 has a global position of 0.5, 0.9, and 0.72. But that same point, if we think about space and time as the bounding box, then that position relative to the bounding box is actually these numbers, 0.47, 0.74, 0.58. So now we could be tempted to be like, oh, if your bounding box Y position is less than 0, go ahead and set yourself to red. And if your bounding box Y position is less than 0, I think I said that backwards, but if your bounding box Y position is greater than 0, go ahead and set your color to red. And if your bounding box Y position is less than 0, go ahead and set it to this cool blue here. Alright, this is going to work. We can turn in for the day. We can take a coffee break. Oh no. Something happened. Our whole particle system is red. That's not what we wanted. Well, remember our trick where we kind of use the geometry spreadsheet to kind of hunt down values? So let's look at this bounding box Y here. Ah, that's interesting. The smallest value that the bounding box ever hits is 0, and the biggest bounding box, or the biggest Y value that the bounding box ever hits is 1. Well, that's the way the bounding box works. It basically says, it basically takes the floor, and it says, okay, that is bounding box Y position of 0. And then it takes the ceiling and it says that is going to be bounding box Y position 1, right? So down here at the floor is a value of 0, and up here at the ceiling is a value of 1. Okay, well that's actually pretty useful, because now we know that between 0 and 1, right, if the floor is at 0 and the ceiling is 1, think about where halfway would be. I'll give you a minute to try to guess. Okay, it's going to be 0.5, right? Because 0.5 is halfway between 0 and 1. So if your bounding box Y position is greater than 0.5, that's actually when I want to set you to red. And if you're less than 0.5, that's when I'm going to set you to blue. So now, voila, we have exactly what we want. And the really cool thing about this is I can move this anywhere in my scene, right? So I can maybe move this whole thing up like 5, right? So now my effect is way up here, and it doesn't matter. It's the top half is still going to be red, and the bottom half is still going to be blue. So now when I play this effect, we get this really cool particle effect where the particles are changing color dynamically as they are moving from the top and bottom half. And this is a very, very simple example, but you can already start to understand the power and the control that we can have over our effects if we understand if statements, right? So don't let if statements scare you. They're your friend. You don't need to use if statements if you don't want to. You could do what I did at the beginning, where you just chop all your entire effect. Let's say you're doing it on a piece of geometry. You can chop it all up and apply different things to different pieces, but next time you run into that situation, you may just say to yourself, my points are going down, they're in these little canoes and they're traveling down this stream, they're paddling as hard as they can. what happens if I take some of those points and I say, hey, you guys go down this little side river here, and then you guys check out this stream, right? That could be a really powerful way of thinking about working, because now you're not restricted to just everyone going down the same river, right? You have these little side streets and side rivers to choose if you want to. So to wrap it up, just remember the way you want to think about if statements is two things make an if statement. You have your conditional, and then you have what code you actually want to run. And remember, this part's easy, right? This part is all of the knowledge, all of the Vex knowledge that you have up to this point will tell you what to do here. The only thing that's different is these conditionals. But even these are not that much more of a stretch, right? It's like we can understand this. We can say, okay, bounding box Y position bigger than 0.5. Okay, yeah, that makes sense. Look, here's a bunch of points that are less than 0.5 in the Y bounding box position. And, oh, look here. Here's a bunch of points that are bigger than 0.5 in the bounding box Y position. So don't forget to use your geometry spreadsheet, right? This thing, like, I cannot stress this enough. I'm sure there are Houdini artists who don't have this up all the time, but I would be surprised. I think this geometry spreadsheet is, if you are struggling and you don't have this up and visible at all times, I would venture to say that's 95% of the time your problem, because I know it was for me. And you might be saying, well, let's say we're doing this example, we're trying to code this, and you might be saying, well, I don't see the information here that I want. You have the power to make it, right? You just make an attribute. Be like, hey, I want to make a new attribute. I want it to be a vector. I'll call it bounding box, and I'll set it to this thing that I'm basically trying to use. And now you have all the power in the world to kind of really understand what's going on. Now, when you're in the production environment, you don't want to leave all of these attributes on your geometry for the next artist, because a lot of times these attributes are really useful for us in our stage of production, because we're trying to kind of figure out what's going on. But a lighting artist might see this stuff and be like, what the heck, this is so messy, right? So, you can delete all your extra attributes at the end, or you can go in, and once you kind of understand what's going on, you can take those attributes out of your code. But don't be afraid. I think the important thing, one thing that really helped me turn the corner in Vex and Houdini is don't be scared to like really grapple with the code and like make the code work for you. Don't be scared to break something. Be like, hey, you know what? I'm going to make an attribute. God damn it, I'm going to make an attribute. And I'm going to basically force it to be 101, right? I don't know why I wanted to do that. I just wanted to show Houdini that I am the master, not you, right? And oh, look, you have to obey me. Here's your attribute, and it's 1 in the X channel, 0 in the Y, 0 in the Z, right? And just doing little things like that can really kind of give you this sense of power and this kind of megalomaniac feeling. But sometimes you need that feeling. That will give you the confidence to kind of tackle like a really, really complicated visual effect that has like a lot of tough mathematical concepts in it. You start to feel less like Houdini has control, and you realize, oh, I actually have the control, right? So that's just, and if statements are another way where you can kind of reassert your control over the situation. It sounds like so like messed up. Like, don't apply this to your relationship with human beings, but in visual effects, it's a really, really useful technique. So anyway, that's if statements. If this second example was too confusing, just go back and watch this first example over and over again. Or sorry, it's deleted now. But that first example where I just took the sphere and I did a really simple little if statement. Just watch that over and over and over again until it makes sense, and then you can try to follow along with this slightly more complicated one. but but honestly, I tried to keep it as simple as I could. But let me know how I did, and hope you guys learned something from this. Thanks for watching as always, and I hope to continue providing educational visual effects tutorials because it's definitely something that I am passionate about. I have a lot of fun doing it, and I think there's a lot of artists who want to do this kind of stuff, but they get intimidated by kind of the coding and the math aspect of it. So my goal is to try